This video is on solution stoichiometry. I'm going to start you off with a question that involves reacting a couple of solutions together. So we have silver nitrate and we have sodium chloride. Now I start off by taking my balanced chemical equation and I'm going to put the information right over that formula for the substance. And you notice for the sodium chloride I have the volume of it. So I'm trying to find out how many milliliters of the silver nitrate are needed to react with this volume of sodium chloride that has this concentration. So the first thing I'm going to do is find the number of moles of sodium chloride that are reacting. And to do that, I have to take the molarity and multiply it by the number of liters, and that'll give me moles. And I've done it right down here. Now, I went from 150 milliliters. Dividing it by 1,000 will give me liters. So that's how we get to 0.15 liters. And now the liters would cancel out, and I get this many moles of sodium chloride. For the second step, I'm going to find the moles of silver nitrate that are needed to react with the sodium chloride. For that, all I need to look at is the 1-to-1 mole ratio from the balanced equation. And so the moles of silver nitrate then will equal the number of moles of sodium chloride. And the last step will be to find the milliliters of silver nitrate solution. So to do that, I'm going to be using my formula again with molarity and volume in it. So I'm going to take my moles of silver nitrate and I'm going to actually take my molarity, which was 0.25 moles per liter, and I'm going to invert it. And this way I can cancel out moles of silver nitrate. Now I'll get liters for an answer, and then I'll convert that to milliliters, since that's what they asked for. And so 90 milliliters is the answer. Let's take a look at another one. Now this question is a little bit different in that you're asked to find the grams of the reactant potassium hydroxide and not the volume. But they did give us the volume and molarity for the lead nitrate. So the first thing I'm going to do is what I did in the last example. Find the moles of the lead nitrate, since I have enough information to do that. And that's going to be molarity times liters equals moles. When I multiply them together, the liters will cancel out. And I get this many moles of lead nitrate. Now I want to find the number of moles of potassium hydroxide that would be needed for this. So I'm going to use the mole ratio from the equation, which is 2-to-1. So you notice now I'll be canceling out the moles of lead nitrate. And I wind up multiplying 2 times the 0.0125 moles to give me my moles of KOH. And these two numbers of moles are in that 2-to-1 ratio. And now I'm going to just convert my moles of potassium hydroxide to grams by using the molar mass. And the molar mass is 56.1 grams per mole. And there go the number of moles, and there's my answer. I can summarize it by just putting all of my conversion factors together, because some people like to see it done that way. And here we go here. So the first step would be taking the liters of lead nitrate, figuring out how many moles that is, then getting moles of potassium hydroxide using the 2-to-1 ratio from the equation, and then lastly the molar mass of KOH. Now in this problem, we have a limiting reactant question involving solutions. So we have a silver nitrate and a sodium carbonate solution, equal volumes, but the molarities are different and the mole ratio is different. It's not 1-to-1. And I want to know how many grams of silver carbonate, which would be a precipitate in this reaction, how many grams I can form. So I'm going to find the moles of each reactant by using molarity times liters equals moles. So when I do it for the silver nitrate, I'm going to take my molarity, 0.20 moles per liter, and I'm going to convert my milliliters to liters, 0.100 liters, and when I multiply them Now the liters will cancel out, and I get that many moles of silver nitrate. I'm going to do the same thing for the sodium carbonate now. So I take the number of moles per liter, the molarity, multiply it by the number of liters, and again the liters will cancel, and I get a different number of moles of sodium carbonate. Now only one of these two can be the limiting reactant. And so now I'm going to figure out how many grams of silver carbonate I could make if each one of these was a limiting reactant. And remember, the one that makes a smaller amount of product is the limiting reactant. So let's see for the silver nitrate. Here's the moles of silver nitrate that I calculated in step 1. The 276 grams of silver carbonate is actually the molar mass of silver carbonate. And in my equation, it just says 1 mole of it. So I'd multiply the atomic mass of silver by 2, add atomic mass of carbon to that, and then add 3 times the atomic mass of oxygen, and I wind up at that number there. Now the 2 moles of silver nitrate are right here in the equation. So I kind of shorten my solution up a bit. But you notice that the moles of silver nitrate will cancel, and I get this value for the silver carbonate. Now I'm going to repeat this process using the sodium carbonate instead of the silver nitrate. And when I do that, you notice again, canceling everything out that I can, I wind up getting a larger mass of silver carbonate. But we know that the smaller mass is really going to be the one that I can make, and this is my theoretical yield. And the theoretical yield comes from the limiting reactant, which must be the silver nitrate. So the answer to the question would be 2.76 grams of silver carbonate. End of the show.